Hello everyone, welcome back. So this is 2-2 Half-Tick Components and their Applications. I'm MU222, and as the title suggests, we would discuss on half-tick components and how you apply them in redstone contraptions. So without further ado, let's get started. So the two main half-tick components, or basically game tick components that you would create game ticks from it, are introduced in 1.14. But then we will also talk about some components that are introduced before 1.14. So here we take a look at this dropper hopper monostable. I haven't touched on any dropper hopper circuits yet because that will be introduced in 2-7 circuits, dropper hopper circuits basically. But anyways, we would introduce them here for now. So a dropper hopper monostable circuit produces a 3.5 tick pulse. So if I click this button, this is a 3.5 tick pulse. It might not seem any difference from a 3 tick or a 4 tick pulse, but there is, of course. So here I have this setup right here. So this is 3 tick, this is 4 tick, and this is basically 3.5 tick, and with these delay. And when I click this button, you can see that these three pistons power at the same time, but then retracts every game tick later, basically, starting from the left to the right. So if I use the game speed mod to slow it down, you can see that they all extend and then they retract one by one. So yep, that's basically, you can see that is a 3.5 tick pulse, and yeah, basically as you have heard, 3.5 tick pulse, so that already includes a half tick rate. But then you do have to notice that not all dropper hopper circuits work exactly like that, because if you add a minecart chest to it, it actually creates a 4 tick pulse. So whenever a hopper receives an item from the minecart chest, it actually gives the comparator a 4 tick pulse instead. So here, if I click the button, you see both extends and retracts simultaneously. And even if I slow it down for just a bit, you can see they just do that simultaneously. So just keep in mind, you have to send it directly from a dropper or from a hopper. So yeah, that is all for dropper hopper circuits. You don't really use them for creating half ticks because they are quite inconvenient. You can only get the half tick from the falling edge. So yeah, but it still remains useful somehow if anyone would use it. But anyways, we would continue on to just simply a redstone block extender. So for a sticky piston that extends or retracts a redstone block, it will provide a 1.5 tick to another piston basically. So I should have added this piston here as well. So when it extends, it has a 1.5 tick delay that powers through this piston, and when it retracts, it also has another 1.5 tick delay that powers through this piston. And please keep in mind that when I say that a sticky piston extends a redstone block, I mean that it extends by a pulse with duration greater than or equal to 1.5 ticks. The reason is because for any pulse length that is shorter than 1.5 tick, basically 1 tick, half tick, or 0 tick, the delay is a bit different. So it has to be greater than or equal to 1.5 tick. So yeah, here you can see in this setup, I have this 2 tick delay. This would be seemingly 2.5 ticks delay, and this would be 3 ticks delay to these pistons. And when I press the button, you can see they extend one by one, each by a half tick difference. So again, we'll slow it down. And of course the retraction is, no one cares. It's quite ugly. Anyways, and then here you can also see the retraction aspects of it. So we have a 2 tick here, and then this is also a 2.5 tick to the piston, and then this is a 3 tick. So if I press this button, when they re-extend, you can see they extend one game tick after each other. So half tick, basically. And then again, we would slow it down. You can see that basically this would be a half tick. You can already see, because this is 1 tick apart and this must be a half tick. So yeah, and the downside of using this redstone block extender is that you can only receive the output with a piston. If you would receive the output with any components other than piston, it would do a 1 tick delay instead, not 1.5 ticks, as you can see in this setup. So this is 1 tick, and this will be another 1 tick. So 2 1 ticks, 2 1 ticks. They both extend at the same time for the extension. The retraction is it though. And same for here. So this is a 2 tick, this is a 1 tick, and the retraction also takes 1 tick. See, they power simultaneously. And the exact reasons of this would be discussed on 2-4, tick counting and more on timings. Is related to piston activation delay. So yeah, for now you just only need to know that you can only receive the half tick delay via pistons. This actually already explains it, but yeah, anyways. So now that we know the pre 1.14 half tick components, which both of them are actually quite inconvenient to use, now we would talk about the post 1.14 half tick components. Here we see a scaffolding. Now let me just talk about the principle of scaffolding. So a scaffolding checks if there is a block that supports underneath it, and it hangs on to other scaffolding blocks if there's no supporting block, and breaks if it is unsupported, and all other scaffolding blocks that are connected to it are also unsupported. And a scaffolding block also changes state when it hangs or unhangs onto another scaffolding after 0.5 ticks. So basically 1 game tick or a half tick. So here I have this. You can see the observer actually detects the scaffolding and powers its piston. Now we can also prove that this is indeed a half tick, because this is 1 tick, this is 2 tick, and then via observer, and this is also via observer, and now we can see that they all power 1 game tick after each other. Let's just slow it down a bit. There you go. So that's basically, you can see that scaffolding is a quite useful block. The setup here, you can see, is also quite simple already. And yeah, and this also shows an example. Using iron trapdoors, you can change states of scaffolding. You know, you can also change with other things, like using a piston. Actually, using a piston that pushes a block, and you can change the scaffolding state. But we usually use iron trapdoors for convenient purposes. It basically fits into 1 block already. So yeah, now we will move on to another half tick component, which is logs and leaves. Now, leaves provide block updates when a log attaches or detaches to it with a 0.5 tick delay. So it can also be detected actually, because it also causes an update to observers. So we have this here. So yeah, this piston is redundant, and it provides block updates. So if I basically butt power this piston, and then I use a log to update it, you can see it actually extends. And when I retract it, obviously it doesn't realize. And then when I retract this log, it will also retract, because the leaf updates this piston. It's a very useful half tick updater basically. And also another property. So leaves can cause an update chain of up to 6 leaves, each leaf adding a 0.5 tick delay. So here we can count 1, 2, 3, 4, 5, 6. This is the 7th leaf, and if I if I press this button, you can see the first 3 pistons do power, but not the 4th piston, because this is the 7th leaf, and thus it wouldn't power, basically. And we can also prove this as a half tick component, because here we can see 1 tick, 1 tick, hopper, observer, 1 tick, 2 tick, and then hopper, observer. So basically 1 tick apart, and then we just fit this into it. I don't know why the button isn't here, but anyways, if I press this, you can see that on the rising edge, they power 1 game tick after each other, basically. And the here also shows, this shows the retraction though. So it is unsync, but then it powers 1 game tick after each other on the falling edge. C. Yeah, basically that's it. So you can see that the extension and retraction the extension has a 1 tick delay, but then the retraction doesn't. So you can always compare these 2 setups to find it out. So yeah, and really that is already all of the knowledge you need to know. Obviously you have to know how to wire them, which is why the exercises would be important. But before I go on to that, I still have 2 more things that I want to share with you. So something that would be useful if you're doing some doors that require speed, or that you will require a specific pulsing of pistons, and that is the armor stand test. And what this suggests basically is that an armor stand would move at various distances when it's pushed by a block whose piston receives a different pulse duration. So there are 3 conditions basically. If the piston receives a pulse with duration greater than or equal to 1 tick, the armor stand moves a full block. So here, if I push this, the armor stand literally just goes off. And same with a 1 tick actually. The armor stand also goes off. So we can identify by the armor stand test that the pulse that is received by the piston is definitely equal to or more than 1 tick. And then here we have 2 setups. This is a half tick setup. This is a 0 tick setup. So if the piston receives a 0.5 tick pulse, then the armor stand will move half a block. So if I just press this button here, you see the armor stand actually stands in the middle of the block basically, or it just moves slightly. So yeah. But then if you 0 tick the piston, then it actually doesn't even move. The armor stand never moves if it's received by a 0 tick pulse, because the piston the block basically just instantly gets into the position of this block right here. So the armor stand never moves, basically. So yeah, and another reason I introduced this is also because of one exercise question that you would come across that would require some knowledge of armor stand test. So yeah, that's why I'm introducing it. But other than the exercise, it's still very useful for you to know it. But yeah, anyways, so as the video title suggests, I would be discussing half-tick components and their applications, so I must provide you with some applications of them. So we come to 2 piston doors I've actually participated in, and I would explain to you why I need those and how it basically works. So the first one is the 400 block 5x5 corner door by me. And just show you how it works. Basically, yeah, it extends after a bit of delay because it's needed in other components that is not shown here. So yeah. So yeah, basically that. So why do I need to use a scaffolding here? Well, it relates to the right slider pistons. They need to push at the correct timing, and it's useful for the retraction, not the extension. Okay, so during the retraction, we shall count the ticks. Basically, this redstone block would come to here, power both this hopper and the trapdoor. Both of these has no delay, so we can start counting on this block right here. So we have 1 tick, 2, 3, 4. So we have 4 tick, and then 5 tick, 6 tick. So this is a triple slime extender. The other one is also actually. Now, this gets powered at 4 tick, so it must get unpowered at 5 tick. This gets powered at 6 ticks, so it must get unpowered at 7 ticks. If I count it correctly. 1, 2, 3, 4. Yeah, 4, and then so this will retract at 5. This would retract at 7. So the blocks, these blocks will arrive at 6.5 tick. So we have two options. We can either power the slider pistons at 6.5 ticks or 7 ticks, because the 7th tick would be that this piston would retract. Now, powering at 6.5 tick is much more preferred, because powering at 7 tick would mean that we need to race between this piston and these two slider pistons, which can come in a bit more complex situations. So powering at 6.5 ticks would seem like the best thing that we can do, which is why I use a scaffolding here. So the scaffolding as 0.5 ticks, so 1.5, 2.5, 3.5. This as 2, so 5.5, and then 6.5, and it powers these two slider pistons. Like so. Now I would give you a slow motion shot. So you see these pushes, and then after 1 game tick, the slime triple extender retracts fully, or starts to retract fully. So yeah, it is not very common to use haptic components for compact doors, but it's still very useful when you need to use them, or you come across some situations where half ticks are more preferable than doing a regular tick, because as I've mentioned, if I power these pistons at 7 ticks, it would cause complications, especially this is a repeater. I'll explain that in 2-3, total priority, racing condition, and their applications. So yeah, I shouldn't ramble too much on this, but yeah, moving on, we have another door. This is the 864 block, 0.45 seconds close or open 6x6 seamless cave door by me and Lumbermando. So the bottom circuit uses 2 log and leaf setup here and here. This isn't that important, but this one would be important. Basically, we have this slime extender that extends very fast and retracts very fast, hence the 0.45 seconds. This is actually the fastest possible. Also, is this 0.45? Yeah. Okay, whatever. So this means that the slime extender has to basically retract on every single piston move that it can retract. So this will retract instantly, this will retract after 3 game ticks or 1.5 ticks, and this would retract 6 game ticks or 3 ticks. Now, you might have heard 3 game ticks. Yes, this piston has to retract at 3 game ticks. Using ordinary redstone components, you are unable to achieve that, basically. So here we have this repeater that powers this piston, but then this repeater would basically turn off after 2 game ticks or 1 tick for repeater input. And then for player input is even more worse. It actually depowers at 1 game tick or 0.5 ticks, which is why this observer is here. So for the repeater input case, the observer powers this line after 1 tick or 2 game ticks. And for the player input case, this observer powers this line at 1 game tick or half tick basically. But then for the repeater input case, this observer would be powering from 1 tick to 2 ticks. And 2 ticks is too much. We need 1.5 ticks. Like from 1 tick to 1.5 ticks, not 2 ticks. Which is why this log here is useful. This log would retract, and this leaf would detect. This is half tick. This is 1 tick, so this piston pushes at 1.5 ticks. This is for both player input and repeater input. So yeah, no matter which case, this observer would be pushed by this piston at 1.5 ticks or 3 game ticks. So this also helps this dust line to retract this piston at the correct timing. The other log leaf setup isn't that necessary. In fact, it can be just a piston and then an observer, to be honest. But then we opted for this log and leaf and then observer setup to make it such that this slider pushes at 3 game ticks or 1.5 ticks, and then this would push such that this redstone block and this redstone block would reach this piston and this piston, so that they both extend at 3 ticks, and they push the block upwards such that the blocks would arrive at 0.45 seconds, which matches with this block. So it's quite nice to see. So you can see they are both in sync. So that also explains to you the usefulness of half-tick components, I hope. Now I would finally get on to the exercises. There are only 3 questions, but for this time, there are a lot of sub-questions. So now exercise 2.1 is the exercise that you would need to use the knowledge of armor stand test. So basically, the main goal is to create a 2.5 tick pulse generator, such that the sticky piston pushes pushing the observer, this one, has the following constraints. So in the left model, you have to use the log and leaf setup, and in the middle model, you would use the scaffolding setup. And then from the results of A or B, or otherwise, you should identify the pulse duration received by the sticky piston pushing the cyan stained glass. So this is where you might think you might see the armor stand test to be useful. And then state whether the normal piston powers, and you don't have to explain because I haven't touched on timings, the explanation of timings. And in the right model, a similar circuit is used to achieve the same positions as the left and middle module. and determine the pulse duration received by the sticky piston pushing this observer, so this one. And then finally, state one similarity and one difference between the right module circuit and the left or middle module circuit. Regarding the normal piston, this one, this one, this one, and the pulse duration of the sticky piston pushing the observer. So you have to find one similarity and one difference between these normal pistons and these sticky pistons. So yeah, that is basically exercise 2.1. 2.2 is funny. So we have a left module circuit that pulses the normal pistons after a certain amount of delay on activation or deactivation of the left button. I shouldn't right click that. So A and B is basically the same thing, but just regarding on different cases. So determine the amount of delay from the activation of the left button to the powering of the normal piston, and the B part is basically from the deactivation of the left button. So this is the left button. Hello. So don't press the right button, it's the left button. So yeah. And then C is using the scaffolding setup. Build a circuit in the right module such that the normal piston, this one, matches the delay of the lock and leave setup for both activation and deactivation. So these two pistons must fire simultaneously for both activation and deactivation of the button. And you might find the results from A and B and the comparing pistons useful. And part D is a short answer question basically. Again, explain one advantage of using the scaffolding setup compared to the lock and leave setup, and one advantage of using the lock and leave setup compared to the scaffolding setup, based on the left and right modules. So yeah. And here comes the exercise 2.3. This is actually a challenging question that I've designed. So here shows a slime double piston extender with adjacent sliders. Build a circuit such that when the lever is activated, the pistons fire to match position A, and when it's deactivated, it returns to the original position. You may change the blocks beneath the repeater, the input block, the obsidian pointed by the 1-tick repeater, and the sine wall pointed by the 2-tick repeater. So you can change these blocks, these, and you can also change this sine wall, this input block, and this obsidian to whatever you please, if you think that is useful. And since this is a challenging question, I also have a hint here. Obviously, it's again a guiding question. Sorry for the thunder in the background, if you heard it. But yeah, if you can complete this exercise without a hint, it is actually quite impressive, because I personally am stuck with this exercise myself for a while. So yeah, but then by analyzing how the timing of the slime double extender, you can infer some hypothetical results that what would be the best timing that these two pistons fire and this piston to fire. So that's all my advice on you for completing this exercise 2.3. It's a challenging question. Don't be upset if you can't complete it, because when I say challenging, it's actually quite hard. But yeah, anyways, for the remaining two questions, they would give you quite a consolidated knowledge on half-tick components already. And of course, Redstone is by doing. So not only do you need to complete the exercises, you should experiment more on half-tick components and how to use them, such that you can grasp a better knowledge on using half-tick components. And obviously, half-tick components are much more useful on fast doors than compact doors, but you see that I do sometimes come up with some cases where I need to use half-tick components. So learning them would be a great tool for you still. And even then, fast doors doesn't mean that they can't be compact. They can be compact and fast doors. So you might also want to learn these components before you start to work on some of those. So yeah, that's basically all I'm going to share with you today. Once again, the answers are at the back, so you can always go to the back or tear down this black wool wall to view the answers. And yeah, good luck on the exercises, and thank you for watching, and I will see you on 2-3, which would be tilting priority, raising condition, and their applications. So yeah, thank you.